by Daniele Maccioni, writing microservices-based web app with Go. Thank you.
Thank you. Okay. Hello, everybody. I'm Daniele Maccioni, and I'm going to talk about microservices with Go. And let's start, okay? So, this is our monolithic application. I think we all are very familiar about that. It's the same classic scenario of single server, backend, frontend, with many functionalities, and usually a single database maybe, and one process, one server, and everything tied together in a single application. This is probably the most common case for us, but today I'm going to try to show you a little bit of something different. I'm sorry. Microservices architectures. What are these things? It's very difficult to give a definition about microservices architectures. We are gathering a few ideas today. The first idea is that I'm going to split my monolithic application into things, into components. Let's say components. Components that are, in our case, services. External services, small external services that are not glued together in a single process, in a single server, but they are split up, maybe in different machines, in different processes. And every single component, every single service should deal with, ideally, with one thing, one domain, one problem, such as authentication, such as, I don't know, image processing. It depends. What's your problem? What's your web application? And I want to have smart endpoints, very smart services, and very dumb pipes. These components, these services, of course, will talk to each other, will communicate to each other in different ways. And I don't want to have a very smart and complex system of communication. All the communication should be dealt by the components, by the services. And I will have this little galaxy of services talking to each other. And of course, something will go wrong. Something will happen, of course. I want to design this architecture for failure. Failure is a fact. The Murphy's law is always there. And I don't want to have a single point of failure in my design, in my architecture. A single service that if it goes wrong, if it crashes, everything crashes. I want my architecture as reliable as possible. And I'm going to achieve these things through decentralization, of course, of two things. Decentralization of functionalities, because I'm splitting up my monolithic application in different services. But I'm also decentralized data. I'm splitting up my single database in maybe many different little databases, each for every microservice, and avoiding one huge cluster of database in the center. And these microservices will talk to each other, and there are many ways to achieve that. It can be like an RPC protocol. It can be something like MQTT or RabbitQTT and so on. It can be an HTTP APIs, but this is an important difference with respect of the monolithic application. We are not communicating through memory, right? Because we will have different machines and different processes dealing together. I would prefer to have a simple and established communication system between all my microservices. I would prefer to have define a protocol for all my architecture and stick with that, instead of having different microservices talking different languages. I would probably prefer simplicity. And when I said design for failure, of course, I don't want to have chain reactions. So I want to have isolation. If a service dies, it should die and respawn without affecting all the system, all the other part of the infrastructure. And this is a very famous image for that by Martin Fowler. In my monolithic application, I have a box with everything inside. Different functionalities, different things, all together. If I want to scale this box, I have one choice. I need to clone the box many times, hoping that's enough. With microservices, I have, of course, a single box for every microservice. That's what it means. It means that I can scale differently each microservice. Each functionality can be scaled in a different way. I can repeat multiple times a microservice that is very under heavy load and not something else. And this is very useful for scaling. I said components many times. And when I said that, I mean a very specific thing. For me, a component is something that is independently replaceable and independently upgradable. And this is the perfect case for our microservice. I want to upgrade my microservice independently, maybe, of course, without affecting all the system, all the architecture. And I want to upgrade this microservice and replace that and maybe find a bug and downgrade the microservice without changing everything in every part of my network. Downpipes. This is very important, as I said before. I'm talking about the routing logic. I don't want this logic to go built in I don't know, in an enterprise bus and in the middle of my architecture. I don't want a router, a complex object in the center of everything that decide who needs to talk with whom. No. The network itself needs to be as dumb as possible. Communication should be simple. A microservice decide that needs to talk with somebody, and he decides who to talk, and what to say, and so on. And the happy example here, the proof of concept that works, is internet. There's no central unit that deal with all the traffic in the internet, of course, right? We have decentralized infrastructure. This is exactly what I want us to do. Internet is our proof of concept. And again, when we talk about failure, it's internet again. If I put online a site or a service with a bug, I'm not destroying internet. And that's a very good feature. And I'm doing the same. If a bug is, if there's a bug in a microservice, I don't want this bug to affect and destroy everything. I'm isolating these microservices and these functionalities. And decentralization, as I said, is the key of functionalities and data. Here, the focus is on the APIs. Instead of trying to glue everything together, we are splitting apart and we are focusing on designing APIs, because the APIs will be the way that the microservices we use to talk to each other. APIs and protocols, of course, of communication. And who's using microservices? It depends on your problem, on the scale of your problems. But pretty much everybody. Amazon, Netflix, eBay, almost everybody. Because we are, why microservices? Because with microservices, we are dealing with something on a different level. Let's say that like this, on a different level. Monolithic is not inherently bad, okay? Monolithic applications are perfectly fine for small-scale problems, and if you are, I don't know, prototyping a service, prototyping a new web application, you are trying to deploy a minimum viable product, it's fine. But with microservices, we are solving organizational problems, and it's a trade-off. We are paying something to get something. We are paying technical problems. We're getting technical problems to solve organizational problems. And these organizational problems are many, a long list, and we can look at them, a few of them. The first one is, of course, scalability. We are solving scalability. As I showed you before, it's easier to scale, and it's more efficient to scale a single service independently from the other ones, instead of trying to scale all the monolithic applications. It's easier. And I'm creating with microservices a structure that it's more reliable. The single microservice is not more reliable than any other piece of software, okay? It's just a piece of software, just a server, it's just a service, it's fine. But the whole architecture, the whole system itself is more stable, it's more reliable. And because, of course, if there's no single point of failure, everything is more stable. The microservices usually will be redundant. I will have many microservices at the same time. And so if there's a crash or some part of the network is not available anymore, something is not reachable, it's fine because there's something else that will deal with that. Everything is more resilient as a whole. And another organization problem that I'm going to solve is not code-based related, but it's about the team. If I have teams that are too large, that are deadlocking each other because they are waiting for each other to finish some part of my software, with a monolithic application is probably a little bit more difficult to deal with these problems. When I have microservices, I can have a little team of people working with just a single microservice. I'm splitting up not just my code, but also my working process. I'm splitting up my teams. Everything is more independent. Everything is more easy to maintain, usually. When I say deployment speed and innovation speed, I'm talking about that every team usually deploys its tests, develop and deploys its own microservice, its own service. And this has many effects, such as that deployment is easier. I deploy independently different things. And innovation, it's easier to deal with a little piece of software, a little service, and even the developer is probably less frightened to destroy everything, right? I'm not dealing with a single monolithic application. If I put a bug in production, it's maybe a big deal. I'm working just on a microservice. It's not such a big deal. I probably be more brave in refactoring or in implementing new features because I can scale everything in a different way. And when I say scale, this is pretty much obvious, I think. The difference between scaling up and scaling out, right? Having a huge server that costs a lot instead of having little service, little servers, and many of them. This is preferable. Our preferable way to deal with this thing is scaling out. I want to scale out everything. And this is the Conway's law. It's very famous, I guess. usually happen this thing that my organization structure has an impact on my code structure. And if I have my teams created around functionalities, such as all the UI specialists apart, all the front-end specialists, and all the backend people all together, and my database experts in their team, I will probably prefer, and I will probably end up with a monolithic application. All the UI team work together for the UI, all the backend people work together for the backend, and so on. When I switch to microservices, I will end up with something like that. Little teams with a UI specialist, a database expert, and coders front-end and backend, all together in the same little team, because every team deals with a microservice. And I'm splitting my code, but I am reorganizing my structure in my company, in my working place. Everything is nice, but of course I am paying a price. What's the price? That's the price. My system is overall more complex. I have problems that I haven't before, such as communication, such as memory synchronization. I need to think about shared memory, shared database, if I have the data that is duplicated around my structure, how to synchronize my data, how to be coherent. If I have daemons that need to be spawned at a certain time, I need scheduling and caching, and even testing is never easy, but it's more difficult here. System testing is almost impossible because I don't have a single application. I have a galaxy of little applications sparse around. How can I test this thing? Logging and telemetry and monitoring become extremely important, extremely important. I'm not dealing with a single application. I'm dealing with a galaxy of little applications. I need to know in real time what's happening, how the load is where is the heavy load, where is the more usage and so on of memory, of resources. I need to monitor all of that, and possibly in real time. And why Go? How many of you are using Go usually for your work every day? Most of them. Okay, so you probably know what I'm talking about, but let's say that again. Go is very, very, how can I say, it's very well designed for this kind of problems. I have parallelism for free in Go, let's say for free. I'm talking about channels and Go routines. I'm talking about a part of the standard library of Go that is built and designed to deal with parallelism. Of course, in my microservice architecture, I will deal with parallelism all the time. I'm living on parallelism for everything. And Go is the perfect tool for the job. He's efficient. He has a very, very efficient scheduler for my Go routines. This huge and wonderful standard library is very well designed and reliable. We are using that every day. It's compiled. It's not, so it's fast. Go is on performance, it's sea level, right? And it has an amazing set of tools, really amazing set of tools. It's a modern language. Of course, you can build microservices in every language you want. And this is part of the deal for to switch on a microservice architecture. every microservice can be built and coded with every language you want. You can have a microservice written in Go, you can have a microservice written in Node.js, in what you want, because they are different processes, right? They are different processes on different machines. They are not tied together, they are not forced to have the same technology for everything. This is a big plus of a microservices architecture. In this example, we are using Go because we love Go. It has a very, very long list of features that we want, and it's very easy even to prototype our little microservice. I want to show you a little example. Of course, it's toy coding, but for example, I have my wonderful startup where I want to scale images. People upload to me images, and I scale them because this is the future of my business, right? I want to do this thing. Okay, so I could, of course, create a single monolithic application. I don't know, Django. Let's say I put everything in Django. I need to decide my technology. So if I said Python, I said Python for everything. For my backend, my database is handled with Python code and so on. And here, in this case, I am trying something different, and I want to split up things. So in this case, how can I say? I find two different features, two different functionalities in my application. For example, I'm serving static data to the client. I'm serving HTML to the client, and I am scaling images. Okay, so let's start to split up. I want to scale images in a different way, in a different service. Okay, and I want to split up things as much as possible. And for example, where's my mouse? Here. Okay. For example, I have my simple where is it? Okay. My server, my Go server, with the classic HTTP handle and func and so on. I'm listening to the port, and the idea is that when people, two endpoints upload and images, and people send me images with the upload endpoint, and it gets images with the images point. Okay. The first thing to notice, okay, I am using this. How can I say this? It's an habit of putting everything in my YAML. Okay, I'm not hard-coding my port in the code. I'm not loading a configuration file from the disk, and I'm using my YAML to get the port, for example, and everything I need. The idea is that I want to eventually publish this web app on a service like Heroku, or maybe on my custom server, on a droplet, on a Docker container, and I don't want to deal with file system as much as possible. I want to ignore the file system as much as possible. And what I'm going to do here, for example, when I'm uploading an image, for example, here, my response writer, my request, this is pretty much the same for everything. I am getting my image file from the client, from the user, and I don't want to, for example, I don't want to download the images on my hard drive. I don't want to tie my images to my file system. I want to use a microservice for that. And I find out that there's a nice service that is Cloudinari, for example. There are many of them that does exactly what I want. It just stores images. Cloudinari stores images. Perfect for me. So I'm not coding anything about that. I'm just connected to Cloudinari. I'm getting the special URL with the connection hard-coded from my env. I'm connected to Cloudinari, and I'm sending my image to Cloudinari, for example. I'm using a microservice made by another person, made by another company. I'm using a third-party service, and it's perfectly fine. I'm glad with that. This little application now is connected with a server from another company that is Cloudinari in this case, and this is pretty much common now. There are, in this case, image as a service, and I'm fine with that. I'm uploading the image. And what I need to do now is I need to rescale this image, okay? And this is, in my view, it's another microservice. This time, I want to build this microservice by myself. So I'm writing a rescaler. How the rescaler and the web app will talk to each other, I need to choose a protocol of communication. In this case, I found MQ is EMQP, right? This is a protocol. There are many of them. And in this case, I'm using another microservice from another company, a third-party company. That's basically I'm connecting to their server, and they provide me a server for messaging and queuing, and I use their server to connect all my microservices together. And when I have uploaded an image, okay, the thing that I do is that in this case, I declare a queue, and I send a message on this queue. I publish a message on this queue. I have a new image. Somebody will connect to the same queue somewhere and take this image and do what he needs to do with this image. In our case, will be the rescaler. Our rescaler will wait reading from this queue, and when he will find an image, he will process this image and will output this result somewhere, and we'll see that. As you can see, my web app application doesn't know anything about the rescaler, right? I mean, there's no connection between them. My web app upload images using an APIs on a service. So I'm using an APIs to upload images. I'm using an API to notify this image, and that's it. Okay. On the other hand, I have my rescaler here. It's a completely different application, a completely different process. It can be hosted everywhere. What does it do? He just wait, connect to the protocol, or the commission protocol. He opens the queue, and he waits. And when he will receive here a message, okay, here a message, I'm of course using channels. I'm waiting for a message on my channel, and when I find this message, I get the ID of the image. This is my protocol. I decided that I'm exchanging the ID of the image. I'm waiting for it, and when I find it, I process it. Of course, this is a rescaling. I do a resize of my image in this case. What I do when I have my image rescaled, I upload it to Cloudinari, for example. So I finished my rescaling, and I upload this image on another service. In this case, it's the same. It's Cloudinari. I'm using this image store as a distributed database for my images. And that's it. I could have like one of these rescaler in background waiting. I could have 10 of them, right? It's the same. They don't have to know anything about the problems of every other microservice. Every microservice deals with its problem. In this case, I wait for an image, I rescale, and I upload it. And that's it. It's a very simple task, very isolated, and very small. And the result, at the end of this thing, is that I have, this is, for example, cloudinari hosted on Heroku, for example. I have my third-party service that stores and handles images. I have my RabbitMQ. This is like my protocol of communication, right? My communications happens here. I can see real time how many packages are sent, how many of them are lost. If I have here in the queues, for example, I can, if internet is working, I can see how many packages are ready, how many there are. I mean, waiting for a rescaler, waiting for the workers. If I see that there are many packages waiting, I can scale more workers, okay, more consumers. I'm producing more than I consume, so I can spawn more consumers. And I have my application here. For example, I upload photos and I see them in rescaled below them. Running out of time. Okay, a few spotlights on this little example. Size matters. Okay, small is better than big for microservice, right? And I'm trying to deal with very small problems separated from everything else. And my workers here, this is the best case scenario probably. My microservices here, the rescaler, is waiting, pulling data, right? And this is very nice because if I have 1,000 of them, they will be all pulling data, and they don't have to synchronize themselves, right? It's synchronization for free, almost. Otherwise, I will need like a service discovery and some more complex system. In my code, I have like APIs everywhere because I have to deal with APIs of my third-party services. I have to deal with API of my scaler and so on. The focus here is moved from a common technology to common interfaces, protocols, and APIs. This is the difference. Usually, if you can, buy is better than build. If there's already a service that is doing what you want, made by specialists in that sector, maybe you can buy the service and use that. Or if it's an open source library, you can contribute with this open source library, but don't do it by yourself again if there's already available. This way you can use the right tools for the right job. You are not forced to create everything by yourself. You're not forced to use a common technology. You can decide that I'm going to use Go for my worker and I'm going to use Node.js for my front end. I don't care. It's fine. Data consistency is a problem. And in this case, in the example, I'm using Cloudinari for an external storage that I upload images without caring about that. It's a nice case to have an external system that ensures your data consistency. And everything is stateless. That's the point. Everything is stateless. I don't want my microservice to save on file system and have an important state because my microservices can die, can respawn, can crash, and if they don't have a state, they just respawn again, and then we start to work again. As I said, no file system. As a last slide, there's a little set of guidelines. Small, maintainable microservices with small teams behind them, single bounded context for every microservice, preferably, one domain, so image rescaling, authentication, front-end management is trying to be more specific as possible, having distributed the data too. Continuous integration would be very nice. And be careful about the speed of your works and the speed of your producers, and watch out for bottlenecks, of course. That's thank you.
Thank you, Daniele. Are there any questions?
I have two small questions. Just you mentioned first that there are workers that are pulling the content from the message queue. What about asynchronous push from your experience towards some maybe workers that are waiting to do some kind of work? And the other question is, you are using like a centralized message queue, in this case RabbitMQ. What is your experience maybe of using some RPC? For example, gRPC is very popular. Can you compare these two ways of interconnecting microservices?
Was about Heroku and
First one was more about workers that are not pulling the content, but rather you push the asynchronous message towards them. What is better approach in your?
It depends on your problem. It depends on the situation. The trade-off is that, if I can say like this, if I have a worker in pool, okay, I don't have to care how many workers I have. Usually, I don't have to care much about synchronization because they will synchronize by itself. If I have more data to process, they will process. Okay. If a worker is in a bad situation and he's having difficulties on the connection, it's a bad connection or some, okay, the balance will be almost automatic, right? Because the worker that has a better connection will eat more data. Okay, I don't have to do anything. In pushing, okay, if I need to push data, I need to know who's there, where, and I need to balance things by myself. I need to there's a little bit of moral logic. I think I'd say that. When about RabbitMQ versus other system, honestly, for now, I dealt with MQ and HTTP APIs, and I never had a real problem that it requires other form of protocols. I'm sorry, I can't do a comparison right now. HTTP is fine too, to have the APIs HTTP. Using a queue, a message queue is maybe better for some problems. It depends. I'm sorry.
Sadly, there's no more time for other questions, but Daniele will be available wandering around. You can find him to ask directly questions if needed.
Of course.
Thank you, Daniele.